Taking a picture of space isn't anything like pointing a smartphone at the sky and clicking. Pointing into the vast unknown with a complex machine equipped with 4 scientific instruments takes weeks of processing reams of data for a final image to emerge. Even after all that, the data is useless to someone who cannot understand it. It looks hardly like anything at all, and not this beautiful color image. You can appreciate all of the data when you know as an expert to look. After making sense of all the data, NASA has unleashed an exceptional photo of the universe, which is swarming with thousands of galaxies, including the faintest objects ever marked in the infrared. These recently released images go deeper into the cosmos than ever before and reveal some of the oldest stars and galaxies. NASA's James Webb Telescope ended the waiting on July 12th and finally delivered the deepest and sharpest infrared images of the distant universe so far. The image features a galaxy field, SMACS 0723, located 4.6 billion years away. The image flaunts many more galaxies in front of and behind the galaxy cluster SMACS 0723. This pocket of color images is the result of 120 hours of observation, which is about 5 days' worth of data. We will know much more about this cluster as researchers begin digging into the data from Webb. The galaxies in the cluster are all very young and formed just a few 100,000 years after the Big Bang. With the help of this powerful telescope and its new images, scientists have been able to explore a period less than 300 million years after the Big Bang, when many of the first stars and galaxies were born. With the images from Webb, we can see backwards in time just after the Big Bang by looking for galaxies that are so far away. The light from those galaxies has taken billions of years to get to ourselves. The images show light rays beat and warped. This is because the powerful gravitational field of a galaxy cluster bends the light rays from more distant galaxies behind it. The stars are also captured with major diffraction spikes as they appear brighter at shorter wavelengths. The initial goal of the Webb telescope was to catch the earliest galaxies, effectively watching the universe turn the lights on for the first time. Before Webb came into the picture, you couldn't see these lensed galaxies with Hubble, and to see them, let alone in such detail, is astounding. Despite being the very first images from JWST, the image shows it all in detail as no telescope has had before. There are a ton of objects in the same frame while looking at these images, in what seems like a 2-dimension. But it's a full-fetched 3D view of the universe. Webb and Hubble before have traveled back in time to take these. The image, consisting of over 2 billion pixels, has a galaxy very much like the Milky Way, which is over 5 billion light-years away. So we're rewinding to 5 billion years ago to look at this galaxy. At cosmic arm's reach at roughly 2 million light-years away, we've got a mesmerizing member of this club, the Andromeda Galaxy. Not only is Andromeda the closest Milky Way-like galaxy to us, but it's also heading right toward us. The two galaxies are to merge in 4.5 billion years, but it's not anything alarming as we've got enough space between stars that anyone still alive will barely notice, aside from some new bright points of light. The new images released of Andromeda will access us to study its stars. While there's still much to learn about our Milky Way galaxy, understanding to what degree other spiral galaxies are like our own, and to what extent there is some diversity of properties. We had Hubble data show us around 5% of galaxies were spirals. The number is at more than 50% with the JWST analysis. This is not because JWST is marking more new galaxies and only galaxies spotted by Hubble were included in the analysis. It is because Webb more accurately determines the shape of these distant galaxies. The Webb images are about galaxy formation more than anything else. More complex forms like our galaxy or Andromeda were believed to have taken time to evolve, and earlier groups of stars were more just clusters. But we're still finding spiral forms even in the early period of the universe. As the earliest stars only had hydrogen and helium to toil with and a short lifespan, what's in those galaxies is probably not the same as ours. It's theirs and later stars' extinction that formed more complex atoms that led to what we see around us now. With the Webb on our side now, we can also observe how gravity and dark matter can quickly form a spiral with enough matter collected in the clusters of galaxies. Does a galaxy have to have heavier elements to have the mass to form structures? That may be something we now have to explore since we can see evidence of them. But would a galaxy have to have heavier elements to have the mass to form structures? That may be something we now have to explore since we can see evidence of them. In this context, dark matter is missing matter within galaxies and clusters. These new images show that spiral galaxies were already a cliché since the early universe era compared to ellipticals. We're pretty sure there are no hidden spiral galaxies nearby, but still plenty of dark matter, even of our galaxy. Do these galaxies have supermassive black holes at their center? If so, how did they form so quickly and build galaxies around them? Well, they've got a lot to figure out now. But figuring out the dark matter dilemma entirely would be helpful for all of us. But that's the beauty of science. Some things are left answered, but we also find out new questions we didn't realize were there. The great thing is how it's been, less than a month, and we're already seeing more things. Moving on, NASA has finally delivered the first atmosphere study of a planet outside this solar system, grasped by the James Webb Telescope. What we have here is the planet GJ667cc, which is even more similar to our Earth than Kepler-22b and was confirmed as a potentially habitable planet just a few weeks ago. In our direct cosmological neighborhood resides our new prime candidate for habitable world, only 22 light-years. Webb, with its 6.5-meter-wide golden mirror and super-sensitive infrared instruments, can decide the shapes of what it sees and count them. We knew we would see things Hubble didn't see, but in this case we're seeing things differently, said Professor Concelis, who also presented some of his discoveries on Saturday, the 23rd of July, at the Blue Dot Festival in Jodrell Bank in Cheshire. The universe is about 13.8 billion years old. So we are traveling back in time with the JWST as it captures glimpses of the processes that formed stars and planets long before our own came into existence. These are the processes we need to understand if we want to understand our origins, said Professor Concelis. This might be the most important telescope ever, he added, at least since Galileo's. James Webb is a joint effort of billions of dollars between the American, European, and Canadian space agencies, with NASA in the lead. All of these images show from the faintest, most distant observable galaxies to planets in our cosmic backyard that you can see with the naked eye from your actual backyard. While we can't yet cruise around in space and have a first-hand view of the unknown, these and many more images make up for the lost chance. That's all for today. If you enjoyed this video, let us know what you would like the next video to be about. I'll be reading you in the comments. And don't forget to hit the subscribe button and notification bell for future updates. See you soon.